All right, hi everyone, good afternoon, or I should rather say a very sunny good afternoon. Welcome to Building for Billions on Android. I'm Kunal and I look after business development for Google Play in Southeast Asia, India, and Australia. And I've got with me my colleagues Ankur Kotwal and Neto Marin from the Developer Advocate team. Together, we're going to be talking to you today about building high-quality apps that will work effectively, not just for smartphone users today, but also for the next billion users as they get connected for the first time in the coming years. We're seeing amazing momentum in emerging markets all over the world. They're expected to account for more than 80% of smartphone growth globally till 2019. As more and more users in these markets get access to devices and get connected for the first time, they will increasingly rely on their smartphones to shop, to transact, to communicate, to look for information, or to simply entertain themselves. And that means incredibly exciting new opportunities for everybody here. In order to be relevant and successful in these markets, it's important for us to think about the important challenges that users face and design the right app experience aimed at solving these challenges. Let's take a quick look at some of these challenges before we get into details. Challenge number one. While we're all excited about the growth of fast network technologies like 3G, 4G, and LTE across the world, the fact is that it's expected by the end of 2020, we'll still have almost 1 billion mobile internet users, or almost 30% of total mobile internet connections to be operating on 2G. That's a sizable and large segment for you to think about and solve for. Secondly, we see a wide variation in the quality and speeds of mobile data networks all over the world. For example, in markets like India, Vietnam, and Argentina, the average mobile data speed is less than 1/10 of what you see in the UK. To top it all, broadband quality and adoption is low. Again, going back to some of these markets, Brazil, India, you see less than 1/5 or less than 20% of total broadband connections in these markets operate at speeds higher than 4 Mbps. Clearly, these pose challenges in terms of the overall experience that users will have within the apps. Finally, data is expensive relative to income levels in several markets, making users highly sensitive to data cost. For example, if you look at markets like Nigeria and Brazil, the average per capita data cost is greater than 10x, or more than 10 times of what you see in the UK. So clearly, being able to help users manage their data cost needs to be an important priority if we have to win in these markets. In order to help you tackle these challenges and support your growth in these markets, we've identified a set of tools and best practices that we believe can help. This is what we call the Building for Billions framework. The goal here is to talk to you a little bit about some guidelines in 6 important areas: connectivity, device capability, data cost, battery consumption, content, and commerce. The goal is to equip you with actionable recommendations that you can implement to make your apps perform more effectively and efficiently in these markets. So what we're going to do over the next few minutes, we're actually going to deep dive into all of these areas. But before we do that, let's take a look at a developer who's already embracing some of these guidelines and have integrated these into the overall app experience that they're driving with their users. I'm going to talk to you about a developer called Culture Alley. They operate an app called Hello English. Now, Hello English is a language learning app helping millions of users in India and outside helping learn English, as simple as that. Right? Let's take a look at a video and see what they're doing.
My name is Nishant Patni. I'm the founder and CEO of Hello English. It's an app that helps millions of Indians learn English in a fun and engaging way using gamification. India is a wonderfully diverse country with 22 languages recognized by the government. But English is the preferred business language. All large businesses prefer to use English.
Hello Hello English supports over 15 Indian languages, 12 of which have native font support on Android. Our users face certain typical issues quite early on. Poor internet connectivity, devices with low storage capacity, low processing power. We decided to focus our efforts entirely on optimizing our app for these issues. We discovered that Google has a bunch of tools that can really help developers to optimize their apps for emerging markets like India. We reduced the app size from 16 MB to 9 MB, which immediately reduced our uninstall rate by 15%. Also, the majority of the features of the app can actually work without any internet.
Today we have more than 13 million people who are learning English on Hello English from not just India but around the world. More than anything else, we are encouraged by the stories that we hear from our learners and how our efforts are transforming their lives.
Inspiring story. What we're going to now do is get into 6 of these areas and talk about specific things that you can start implementing to drive and boost performance of your apps in these markets. And by the way, what we're covering here is by no means limited to emerging markets. These are good principles to apply equally everywhere globally. Let's start with connectivity. In order to optimize performance for poor or intermittent connectivity, it's very important that your app prioritizes bandwidth requests in order to ensure that users have access to the most useful and relevant information as soon as possible without having to wait on slow networks. Ensuring that text is prioritized before rich media and images helps you accomplish that. Let's take a look at an example. In this demo, you will see that the text loads way before the images so that the user can actually start engaging with the app despite being on a slow network. The second thing that I'm going to talk about is something which is often overlooked by developers. You should not duplicate your data requests. Once you fetch something, you should be able to store it and then resurface it locally whenever it's requested the next time. Network connections and overall quality is not static. They change with changes in location, network traffic, as well as the local population density. And your apps should be able to pick that up. And by the way, like I said, this is a problem not just confined to emerging markets. This could happen very easily in the underground subway in New York or a crowded football stadium in the UK as well. Using tools like the Connectivity Manager and Telephony Manager, your apps can actually detect change in bandwidth, change in networks, and then adjust bandwidth accordingly. So we highly recommend that you take these into account as you think about optimizing for poor networks. Let's talk about images. I'm sure all of us have images or lots of images in our apps. Images need special attention as you think about optimizing for connectivity. As a best practice, serve WebP images. WebP is a format which has been fully supported by Android since 4.2. And regardless of what the name suggests, WebP is not just restricted to the web. WebP helps you improve load times, save network bandwidth, and in many cases often results in smaller picture sizes compared to formats like JPEG and PNG, while maintaining the image quality. So it's a highly recommended practice. Your user experience can degrade very quickly if they're waiting for long times to actually download images. I'm sure everybody would agree with that. One way to counter that problem is to ensure that you use the appropriate sizes of your images. So consider prioritizing image requests based on network type or quality. Right? This helps you not only save network bandwidth, but also helps you optimize for the memory that each image will require on the device. Offline. I think creating a great offline experience is a wonderful way of ensuring that your users will be able to engage with your app content irrespective of what the connectivity is like or whether it doesn't exist at all. Right? Ensuring that users have a great offline experience by making sure that you're able to cache data, store it locally, and also queuing outbound requests for whenever the connectivity is restored. Your app should not be required to actually fetch any image more than once. So image loading libraries like Glide and Picasso actually help you fetch the image, cache it, and then plug into the placeholder views that your app has without needing to download them again and again. This can all overall help you boosting the overall user experience and overall performance that users have within the app. In this case, you will see that while the app is offline or the user is offline, they do still have a very meaningful experience within the app with the information and the data that's already been cached. One simple way of checking how your app performs in the offline state is by simply switching on the airplane mode on your phone and checking it out. That gives you a very, very good example, a very good insight into what kind of performance, what kind of functionality is working well when the app is actually offline. So go ahead and try it out, and if it's not, then do think about some of the other things that we've spoken about to improve performance in poor networks or offline states. With that, we come to the end of the first section on the 6C framework, as we like to call it. I'd like to now invite Ankur to talk about the rest of the Building for Billions framework. Thanks. Ankur?
Thank you, Kunal. Hi, everyone. So Kunal has given us some great context around connectivity, and I'm going to start talking about device capability. As the next billion users come online, and actually, this is true even of the current 1.4 billion Android users, there is a diversity in the type of devices that users have. Some users like small, light devices, others like big screens with high definition, full HD, or even 4K resolutions. Some users like expandable storage, whilst others prefer a really big, rich camera. And while this is great for users, it poses some interesting challenges for developers. So let's look at some things that we can do, best practices developers can use to support all of these device capabilities. And let's start off with screen sizes. The majority of devices that will be bought by next billion users are actually going to be low-cost devices. And of course, with low-cost devices, you tend to find that their hardware specifications tend to be a little bit lower. You want to start to look at your layouts, right? And start optimizing for small screens. Small screens will be popular, but actually moderate-sized screens with lower density will also be hugely popular. And those are really important distinctions. With small screens, you want to reduce the amount of UI that you have for navigation, for actions, because you want to let the content shine, right? When it comes to density, however, low-density screens, medium-density screens, you want to make sure that the same content that you're displaying is easy to consume, that the text is easy to read, that the images look sharp. And particularly where you're using graphical assets in your icons or action icons, you want to make sure you're not using like thin edges on those icons, because on a lower density screen, those thin edges, they'll disappear. And of course, you can test this out. Android Studio has been running hard with productivity improvements, and one of the things that they've focused on is improving the emulator performance. So what you should be doing from a screen size point of view is setting up multiple emulator configurations and then deploying your app to these smaller screen sizes or lower densities and testing how it looks on those screens. And you can make rapid changes in the layout editor now because Android Studio has instant run. So when you make a change and deploy it on the emulator again, it's not repackaging your whole app and distributing it. It's just sending the changes across to your running app. So the turnaround time is much faster. So we can actually make these changes rapidly. Of course, next is memory usage, because low-cost devices will have less RAM. And I just want to clarify, when we talk about memory here, we mean RAM, not storage. We'll get to storage in a minute. You want to adjust your behavior by the amount of RAM that's on the device. And there's one API that will raise lots of warning signs, and you should be using it today. And that API is low RAM device. If that API returns true to you at runtime, you know that in your app, you need to be aggressive about keeping your footprint down, because this is a very constrained environment that your app will be running in. The other API you can use is getMemory class, and that helps you understand how much memory budget you have in your app. Now, strategies that you can use to lower the memory usage are things like holding on to things in memory for a little amount of time, being more aggressive about releasing it, not keeping it in memory. Images also consume a lot of memory, so when you have a low RAM device, or when you have a device that you know you've got low memory budget on, just use a lower resolution, even if it's slightly lower resolution than what the device will be rendering at. Because then you'll still be able to let that user use your app and have a decent experience. And we all love to build apps that do background processing, right? Many of us build apps that have services. That's okay. But what's really bad is when you have a service that hangs around, that starts up and sits there consuming memory but refuses to go away, right? Because if every app on the system does things like that, that means there's less free memory available for foreground apps, for the apps that your users are actually interacting with. So as developers, we should start up, do our work, and then shut down and wait to be woken up again. And we can schedule those wake-ups with an API called GCM Network Manager. I'm going to talk about that API in a few more slides. But it's really important to stop long-running processes. Let's switch gears now, in a minute, actually. I want to show you a screenshot here for comparison, and this is actually the Android Studio memory monitor. We've added a number of tools in Android Studio that help you benchmark how your app runs, and so you'll see these two graphs. On the left-hand side, we have a device with 512 megs of RAM. On the right-hand side, 1 gig of RAM. And you look at the graphs, and the shapes kind of look the same. It's because it's the same app running across those two configurations. But what's important is those figures in red. You'll see on the 512 meg RAM device, we're using about 12.5 megabytes of RAM, and on the 1 gig RAM, we're using 36 megabytes. It's the same app. It's actually adjusting at runtime to its memory usage. That's why the shape of the graph looks the same. Those requests are the same, but we're being smart about how much memory we're using. And that's what you should be testing. Again, use Studio's memory monitor and the emulators, or even physical devices, to see how your app performs. Now let's switch to smart storage. Kunal gave us some fantastic advice. You do not duplicate network requests. You should hold on to them. You should cache them. But that doesn't mean you should cache things forever. The size of your app in storage should not grow infinitely. And that's why I recommend you bound your caches by using things like the disk LRU cache, or least recently used. What that will do is actually only hold on to the things that are being used regularly, and old things, it will expire them and remove them from the cache. Now, if you think about the user's experience when they run out of storage, low-cost devices, by the way, don't have a lot of free storage to start with. But when a user runs out of space, what happens is that they get a notification on their device. The Android system says, you're out of disk space, you should go and uninstall some apps. When you tap that notification, it takes you to a list of apps, right? And they're sorted by how much space they take up. Now think about it. The user is going to uninstall those apps that are towards the top of the list, because installing 1 or 2 apps, they can move on. They get rid of the notification, they get updates, they can interact with other apps. You don't want your app to be on that list. So here's a tip for you. When you're caching your data, use this API, get cachedir, and store your cache in that directory. What that will do is that when the system detects that it's running out of storage, it will clear out the system cache, that cache, before it lets the user know. Right? So you get a chance to not end up on that naughty list. And actually, often what will happen is when the system does this, you'll find that the system actually frees up enough space on the device that it doesn't need to warn the user anyway. So one, you're being a good citizen on their device. 2, you're keeping your app out of the naughty list of system apps. Now, many users you'll find that they use expandable storage because the main device comes with only a little amount of storage. And so what you want to do is enable your app to be installed to the SD card. And that's just a one-line change in your manifest. You don't want to make certain assumptions, though. But it's really important that you allow this so that the users can have more apps. And last of all, if you look at the screenshot, that's just the system settings app. And we're just looking at our app in particular. This is an app that I wrote. And you can see exactly how much storage you're using. So you should periodically do that for your apps that are in development. See how much your caches are growing to on various devices. This image actually took me a while to find. It's really, really important that we are backwards compatible for our users. Especially in low-cost markets, what you'll find traditional user behaviors is that either they are so price sensitive to the devices that they buy that they'll buy a second-hand device, which is older, or when they go to buy a new device, their existing device, they will pass it on to a family member or a friend. And so what we see is a longer tail of device life cycles. So it's really important that you make your app available to all those users. You should target your minimum SDK to be API 14, ice cream sandwich, because you'll reach most of your users there. But you should always also set your target SDK version to 23. 23 is currently the latest API, which is Marshmallow. And in a few months, it will be Android N, whatever the name tends to be. And it could be API 24 or higher. But you always want to target the latest API, because that makes sure that your app benefits from the platform features that come on Android with newer releases. Minimum SDK of 14 will make sure that Android Studio will warn you if you're using those features without checking for those API versions. So having this combination gives you this fantastic position where you can have the latest and greatest features on newer devices, but be able to support your older users nicely. And of course, we make this easier with the Android support libraries. Everyone should be using Android support libraries because they provide backward compatible components for you to integrate into your apps. And in fact, one of them, which I'll talk about later, is the design support library that makes your apps still stay modern. Google Play Services is a library that we distribute automatically to all devices with Google Play. And it brings the best of Google's APIs there. And the nice thing is you can use Google Play Services APIs and know that your users will have them. So please do use Google Play Services where you can, because your users will continue to get the benefits of those updates. All right, device capability was a big one, but a very important one. Kunal mentioned that data can cost up to about 10% of an individual income. So it's really important that we respect that when we use data of our users' data. And the first one that we need to think about, the first cost that our user incurs, is just installing your app, right? We need to keep our APK sizes small. And there was a great talk called Putting Your APK on a Diet at I/O this year. So if you didn't catch it already yesterday, you can catch it on YouTube now. But what I want to share with you is that images are really the biggest offenders. Kunal mentioned it earlier for data that we were transferring over the network, right? Use smaller file sizes. When it comes to APK, you definitely should use WebP, but you should also consider using SVG, Scalable Vector Graphics. Because scalable vector graphic images, or SVG images, tend to be these tiny text files. But the cool thing about them is because they're vectors, they render to any resolution. And so they're perfect for your graphical assets, right? Like your icons in your navigation bars and so on. And it also means a single SVG is all you need to put in your APK. You don't need to render an LDPI version, an HDPI version, an XHDPI version. It's a tiny file to start with, and it supports all the densities. You also want to keep your code small, and ProGuard is the way to do that, because ProGuard strips out any code from your APK that you're not using. Often our code bloats over time, and ProGuard is there to help. So minify enabled equals true, and shrink resources equals true will also strip out any resources or code you're not using. Now, many of us use third-party libraries. I just suggested some libraries earlier. I suggested the Android support library. That's built for Android. When you're selecting any libraries for your own apps, be very careful that those libraries are designed to be run on a mobile platform, that they're not these gigantic libraries that pull in lots of code and bloat your APK. Typically, libraries that work best on Android are the ones that are purpose-built. And if after all this, you're still finding that your APK is too big, and by big, by the way, your target should be 10 megabytes. That's what we find to be the sweet spot in many of these next billion user markets. If you're finding you still are very far off it, multi-APK is a great option, because when you enable it, and you do a build, rather than ending up with a single monolithic APK, you can split your APK by density sizes. So when a user with an LDPI device installs your app, they only get LDPI assets, because that's all they need. They're not burdened by these high-resolution files. And the reverse is also true. People on high-resolution devices or high-density devices don't get these low-density assets that are unused. There's a little overhead for you when you go to upload to the Play Store. You have to upload a few more APKs, but it's totally worth it. Data use is really, really important when we're talking about data in transit. And so what I'm going to show you here is that same app that we looked at earlier, Yokel, the one that we built. And here what I want you to look at is the 3 peaks that we start with here. These are the text requests. And almost immediately, you see them becoming really small and practically down to 0. And the reason for that is because after requesting those text that we were displaying to the user, we request images. This is an example of that prioritization that Kunal talked about, where we requested the text first, provided meaningful, useful information to the user, and then started getting the heavy work. Please run your apps through the network memory monitor and see what your behavior is like, see what your experience is like. And ask your users during the warm welcome as to what kind of usage you want from your app. Do they want you to prefetch information ahead of time? You don't have to make that decision for them. Because we have a diverse range of users, it's always hard to find a one size that fits all of them. It's okay to ask them in a nice way that makes sense. Everybody loves their smartphones. Everybody hates their smartphones when they die because they've run out of battery. And apps are usually the contributor to that. Now, when we talk about low-cost devices, of course, it means that they're going to come with smaller capacity batteries. So it's important for us to focus on optimizing our battery use. The first thing we should do is ensure that the device is not being kept awake unnecessarily. So go ahead and look for wake locks in your code and remove them, all of them if you can, but certainly as many of them as you are able to. Because a wake lock, holding onto a wake lock, tells the device that you can't go into a low power state, that you can't go into standby. So even though the screen is off, the CPU is fully spun up, and that's bad. That destroys battery life. What we should be doing is firing up our component, waking up when we need to, doing our work, and shutting down. Not holding onto wake locks, not leaving these long-running processes like I said earlier. And the way that we can do that is with this API, GCM Network Manager. Now, I know it says GCM in there, but it's actually not specifically about Google Cloud messaging. The API is named what it is, but trust me when I say what you use it for is to schedule tasks, and it uses the job scheduler on Android versions that support it, or falls back gracefully on versions that don't. So you have a single API that supports all your Android users. And the great thing about this is that it can wake up your app with conditions that you define. So not just at this particular time, but you can say things like when the device is charging, when the device is connected to Wi-Fi. And if you think about those two conditions, they're, they're very relevant to these billions of users, because you want them to be able to consume this data when it's not costing them a lot of money, right? Not on their cellular networks. You want to do it at a time where you're not chewing up extra battery, i.e. when it's charging. So use GCM Network Manager for all your scheduling needs. If you're using Alarm Manager today, that's something that you should look at changing immediately, because GCM Network Manager is magic. It's fantastic. And of course, when your app does wake up, don't have it do something really tiny, shut down, and then wake up repeatedly. It's better to batch our network requests. If we've got 3 things that we need to do them together and then shut down, because then the device is able to stay in that low power state for longer. Batching is important. We've talked about lots and lots of different technical details, but of course how we present our information to our user is the thing that you must solve, right? So let's look at content. Touch ripples are really, 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 really important. I can't stress this enough, because when we think about our devices, when we touch the screen, we need immediate feedback from our apps. And touch ripples are one way that we do that feedback. We provide it. And often I find apps where I will have like an index of content, I will hit that content. Not only will it not give me any touch feedback, but it will be unresponsive until it pulls out the details page. And that's bad. If you're fetching any data locally or over a network, your app should always stay interactive. Provide some sort of visual feedback to the user that you're busy doing something. On lower spec devices, this is even more important because it takes them longer to do all of this. On a lower connectivity, it's really important because it takes longer for them to fetch that data. Now, Android devices render the screen at 60 frames per second, and you should always target that. We have tools in the system setting that allow you to see how often you're able to update your screen. So have a look at the overdraw settings in developer options and see how your app is performing there. And finally, when we launch new apps, when we launch our app for the first time, sometimes it can take a while to set up. Again, you want to show your user that something's happening, so consider using what we call a launch screen, which is typically a big activity that's a single color and a light image. What that does is it says to the user, yes, I'm loading, I'm telling you it's coming. And that's setting the right expectation, that it might be taking a while, but I'm here. And stay responsive. Material design makes it easy to build for devices that are small as well as big. Screens that are tiny 2-inch screens, screens in our cars, projected screens that are 40 inches. Oh, this is probably more like 100. And so please adhere to those guidelines. It also means that when a new user uses your app, they're already familiar with how to use your app, how to navigate, how to go back. Right? They're used to that consistency. And the design support library, which I mentioned earlier, is part of the Android support library. We provide backward compatible material design components that look great on the modern versions of the Android operating system, as well as on older versions of the operating system. You get that full backward compatibility that I talked about earlier. So the design library is really where you want to go to get your material design components. There are also some great community libraries that you should look at as well. Material design is something that's interpretable by lots and lots of developers. So we provide some great stuff in the design library, but the developer community is always moving ahead as well. And there's no point trying to build an app for an audience if you don't speak the same language as them. So consider their locale. Consider which audiences you're reaching. You may need to change what language you support, how those layouts look and feel on various languages, because sometimes they're smaller, sometimes they're bigger. And you want to make sure that the text is really easy to read. So choose an appropriate font, particularly when we talk about low-density screens. If that font looks blurry at size 14 or 16, you've lost your user because they can't read it. We support Noto. We've provided this open source font that supports many languages, and you'll see some Indic languages here in the screenshot. But try and identify the right one. But remember, there is a balance in shipping your own font in your APK or using a system font, because if you ship your own font, it adds to your APK size. So just take that into consideration. So we've talked about a lot of technical things, but at the end of the day, we're all part of a business. We want to be commercially successful. And in order to do that, I'd like to introduce Neto back on stage.
Hey, thank you. Well, as you can see, we have many considerations when we're talking about how to develop apps for these countries, right? And when it comes to monetization, there are also unique facets to consider. So, in this kind of markets, in next billion user markets, as Kunal and Anko already mentioned, the users are kind of sensitive to price, more so than the other countries, right? And therefore, it's important for you to keep it in mind when localizing prices to these markets. So, for example, let's take a look at ways to monetize in such a diverse environment. The classic methods you can use to monetize your app could be advertisement. So please use AdMob, for example. We have in-app purchase to sell virtual goods or implement a freemium model if you want to do that. Also, you can use subscriptions to offer a recurring billing for app or your service. And of course, you can charge for your app as a paid app. Okay? But in order to give you more flexibility to set prices, we've announced new pricing levels in 18 markets. Yes, 18 countries where you can price your app or your in-app item well below $1. So, for example, in Brazil, you can price as low as R$1, it's the currency in Brazil, and in India, 10 rupees. And as you can see here in this screenshot, we have many developers that already embrace this sub-dollar feature, and it would be great if you can think about how to localize your price to these markets. Here's another example. It's a successful, it's a famous paid game, Kingdom Rush. They saw tremendous success after adopting the local price feature. They are reaching 200% more revenue, even with a lower price. And how is this possible? Lower price? Yes, because now they're more relevant. They can reach many more users with this local price. Okay? So, yeah, today we covered the challenge that developers face when building apps for billions of Android users. And to address this challenge, we've introduced the Building for Billions framework. Using this framework will result in a great user experience for the both 1.4 billion Android users and the next billion as they come online. Okay? And also to check these links for more details about the Building for Billions framework, have both Android and web framework information. And also, we've published a playbook that captures the best practices for building for billions on Android and web. And you can get one now on Google Play. And also, you can get one copy of your book right on your way out. Okay? Thank you for being here. Bye.